Okay, guys, so continuing on today with the next lesson of our financial math unit, we're going to be looking at something called annuities, okay, and in particular, the future value of an annuity, okay. So before I get into any of the questions, let's first define what an annuity is, because more than likely you probably have not heard that term before. So an annuity is a series of equal payments or deposits made at regular intervals over a fixed period of time, and an annuity earns compound interest. Okay, so the key here is equal payments or deposits at regular intervals over a certain fixed period of time. So examples of annuities include here car payments, mortgage payments, loan payments. So what makes these fall under the category of an annuity? So something like, let's say, any one of these payments. Let's take a look at mortgage payments. For mortgage payments, you would be paying, generally speaking, a monthly mortgage payment. And that takes care of the regular interval part because your payment is made every month. So it's made at regular intervals. So it could be every month, it could be every 2 weeks, it could be every year, whatever the case may be. But it has to be at the same interval every time. And the other part, it has to be the same payment every time. So if you look at mortgage payments, your mortgage payments every month will be the same amount for the life of the mortgage. So a lot of times mortgages can be, I'm thinking the most popular one is probably a 5-year mortgage, but you can get mortgages that are less than that or more than that. But for it to be an annuity, it has to be over a fixed period of time. Okay, so the same payment at the same interval for a certain amount of time. That's what makes something an annuity. Okay. We have a definition here for ordinary simple annuity. I wouldn't worry about that too much because anything we're going to deal with for the purposes of this course will be an ordinary simple annuity. Okay. So in terms of how to calculate values for annuities, there's 3 methods in this note. We're going to look at 2 of them. The first method here is the timeline of an annuity. So here you basically draw out a diagram showing the timeline of all of your payments. Okay, so let's look at the question here first. Wilson is saving for the down payment on a new car. He plans to deposit $1,000 at the end of each month into an account that pays 3% annual interest. So annual means per year, okay? And it's compounded monthly. So first off, what makes this an annuity is it's the same payment, right? Equal payment of $1,000, and it's at the same frequency or regular intervals, which means in this case, it's every month, okay? And it earns compound interest, and the question tells us compounded monthly. So to do the timeline method, we actually draw out a diagram showing each payment that Wilson is making over the 6 months. Okay, so it says he deposits $1,000 at the end of each month. So we can see here at the end of the first month, $1,000 at the end of the second month, $1,000 at the end of the third, fourth, fifth, and sixth months, $1,000 each time. So to use the timeline method, what we need to do is basically look at each payment of $1,000 separately, figure out how much interest each payment makes by the end of the 6 months, and then add all of the values together as you see done over here. Okay, so let's look at the first payment as an example. At the end of the first month, he pays the $1,000. And how many months do you have left at this point in your investment? Well, if it's the end of 1 month and then you have 6 months total for the life of your investment, that means you have 5 months left. Okay, so we have to figure out how much interest this $1,000 will make over 5 months. And we do that down here by using our compound interest formula. So if you remember the formula from previous lessons, it's A, which is the amount, equals P or PMT, which is your payment that you start with, so $1,000. And then bracket 1 plus I to the power of n. Okay, so the I in this case, we can see up here, it's been calculated for us. So the I is the interest rate. So there's your 3% in the numerator, divided by how many times it's compounded in a year. So because this question says compounded monthly, that means interest is compounded or applied 12 times in a year. So for our I value, we take the 3% and divide it by 12, which gives us 0.025. So in this bracket, 0.0025 is what this is. And then N is the number of compounding periods. So we just said we have 5 months left in the investment. And because it's compounded monthly, this N value, we have 5. Then the payment you make after 2 months, $1,000. The only thing that changes now at 2 months, you have 4 months left, right? From 2 to 6. So the number of compounding periods is 4. And then at 3 months, you have 3 months left. So the number of compounding periods is 3. At 4 months, you have 2 months left. So number of compounding periods is 2. 5 months, you have 1 month left. So technically this is power of 1, but as we know, we don't have to write it there because it doesn't change anything. And then the very last payment at the end of 6 months basically is going to earn you no interest because you are making that payment on the last day of the investment. So there's no time left, meaning there's no interest on the 6th payment, which is made at the end of the 6 months. Okay, so you figure out the amount each monthly payment is worth, which we've done over here, add them all together. And this tells us that Wilson's investment of $1,000 at the end of every month for 6 months will be worth $6,037.63. Okay, so that's the timeline method. You can see how it can be time-consuming. Now imagine if we had said this investment was going to last for 24 months or 36 months or something larger than that. Then you'd be sitting here drawing this timeline out for 24 or 36 months, which would take you a fairly long time. So good news is we don't have to use a timeline method for answering questions or finding these values. We do have a formula, which we'll look at in method 3. But before I get to method 3, just very quickly, we're not going to be looking at method 2, which is using a TVM solver. So any questions you see in the homework involving a TVM solver, you can skip those. Okay, so moving on then to the formula method. So here is your formula. If we were to have a test on this, like if we were in class, you would be given this formula, so you wouldn't have to memorize it. You just need to know, as always, what each of the variables stands for. So here we have the first two. The FV stands for future value. So the future value will tell us basically what our investment will be worth at some point in time in the future, in this case at the end of 6 months, because the question says the investment lasts for 6 months. The PMT is the regular payment amount. So in this case, it says Wilson deposits $1,000 every month, so 1,000 is your regular payment amount. Okay, so those are those two. The I and the N stand for the same things as they stood for in the previous lessons in terms of compound interest. The I is your interest rate divided by the number of times that interest is compounded in a year. So again, just like above in the timeline, interest rate of 3% gives us 0.03, and compounded monthly means 12 times a year, so divided by 12, and our I value is 0.0025. Okay, N is the number of compounding periods, and here, because it's compounded monthly and the investment lasts for 6 months, that means we have 6 compounding periods, so you have to the power of 6 here. Okay, so once you have all your values, plug them in, and at this stage you let your calculator do the rest of the work. Just make sure you're doing everything in the correct order. So following BEDMAS rules, we look inside our bracket. First thing we would do is do this 1.0025 to the power of 6. Take that value, whatever that is, and subtract 1, and that tells us the numerator here is 0.015094. Then again, using BEDMAS, do the bracket first. So dividing this out gives us 6.0376. Multiply that by 1,000, and we get the same answer as we did with the timeline, which makes sense because it should be the same value because it's all the same parameters in the question. So his investment after 6 months using the formula is worth $6,037.63. Okay, so those are the two methods that we'll use for future value of an annuity. So you have your formula, which is given right there. And then you have the timeline method, which we did up here in method 1. Okay, so as always, the practice questions are on the, the blank version is on the blank file that I've included for this note. And then this filled in version with the solutions is on the filled in version of the note. Okay, as always, any questions, let me know, and we'll leave it at that.